So we'll get started. So I just thought I would update people on what I've been working on. I know that I posted some things to Facebook, but I thought I'd just go through what I'm actually up to. So it's quite interesting working closely with Tony. So after I finish my presentation, Tony's going to talk about his thoughts on the problem that I was seeing. So yeah, just another Neopixel adventure. And also thanks for Ben Clifford for his help recently with the Neopixels. So yeah, I was just thinking about a project I did once before. So just providing this status of the tube lines in London here, did the first time using EL wire, electroluminescent wire. I found that kind of hard to control, and it's kind of fiddly. So after Ben Clifford did his talk about cheap Neopixel strings, I picked up a few strings myself, as per the picture there. So there's 10 meters, and it's 100 Neopixels. So I guess the good thing about these is it's not like a strip. They're like one after another within half a centimeter or something like that. They're spaced out 10 centimeters per light. So then you can use them however you want. So my first version was a Perspex version, and all I did is I thought I'll just hot glue the Neopixels to the back of the Perspex, and it's what you have here. So this is showing the tube lines that I'm working on at the moment. So you've got the Metropolitan line feeding into the Circle line. This is sort of the central of London here, for people that don't know it. Then you have the District line on this end and District line going out this way. So it just shows, I think I did every third station or something like that. And then I realized there's too much bleed through the Perspex. You can sort of see the Perspex here has got this coloring. So I thought we'll just try some cheap wood that I had lying around. This is version 2, which looks a lot better. There's no bleed over, obviously. So I just drilled, I think it's 3 or 4 millimeter holes in the board, and just glued the Neopixel to the back of that. I sort of strung it all the way around, just because obviously between these two lights is not 10 centimeters. So this may be one, and then I'll skip one and then come back and do this one. So it's all a bit of a bird's nest in the back, but it sort of works. But it does mean you have to have a database that sort of says, well, this pixel is this station, that sort of thing. So but it works quite well. It looks quite nice. So I thought I'll continue with that. And you can see you can get pretty good color resolution here against all the lines. So I was quite happy with that as well. So then I thought, well, I'll make it a bit bigger and do all the stations. So I got these professionally printed map. So I got a black and white one and a color one printed at the same time, and put it back on some very thin ply. And I've started drilling the hole. So I think I've drilled the northern line, which is the one in the center here. So I've drilled about 40 holes already, just 230 left to do. Which doesn't sound like a lot, but you do want to be precise. So it does take a while to drill each hole to make sure it's actually going to work. So each pixel string, as I mentioned, had 100 pixels. So then I need 3 strings together to make the 272 that I need. And also accounting for some wastage. The issue is when I hook them up. So I think this is the first one, then this is the second one, and this is the third one. So even when I was just driving the first few pixels red, you can see the first few pixels red on here, and then it's a whole bunch of, I think that's green or maybe blue. And then this string was copying exactly the same thing, which struck me as really strange, and this one as well, even though I wasn't even driving them. So it turns out that each of these LEDs actually has an address. I don't know how they program them in it or solder it in, but it does have an address. So even when I had to cut off some Neopixels because I damaged them or whatever, it still knew like pixel 1 still knew it was pixel 1, even though pixel 0 was no longer there. So I don't know what the advantage of these sorts of neopixels are. I imagine if you want to just repeat a bunch of things over and over again across many strings, then I guess that'd be an advantage, but I'm just not sure there's much of an advantage. The other issue I found is that you can damage an individual pixel, so then it doesn't understand its address properly. So if I'm driving pixel 28, for example, like pixel 25 might actually light, depending on where the bit error is. So it just feels like far too fragile. I'm not sure it's necessary. I don't really know what the advantage is. So I thought, well, I'll just buy some new pixels. They're not that expensive. I did buy some new ones. And I bought these ones. You can see that. Bought these ones, but I have no idea how these work. I assume they were neopixels, but when you open up the box, it's only 2-wire protocol, so I don't know how that works. So I thought, well, okay, I'll just try to get this working as it is. So yeah, so I was really struggling with, what is this? Why is it doing that, and how is this actually happening? So thanks to Ben Clifford, he realized that he'd seen at some point these fixed address pixels. Yeah, so at this point I just realized, well, let's just learn how to deal with these extra pixels and deal with them individually. And I couldn't really find anything about how to do it online. So there's lots of the similar question saying, how do you drive multiple strings from one pin? Because I think everyone realized you use pin 18 to do a lot of the pixel driving. And I just couldn't find anything online that would do that, drive individual pixels. So what I thought I would do is use a demultiplexer. So this is the Toshiba TC4051B, and the way it works is you put in, you tie some of these to ground, so you have inhibit to ground, which I didn't initially have tied to ground, so that's important. Obviously, if it's called inhibit, it should be tied to ground, not high. VE and VSS both tied to ground. VDD is your command voltage, so 3.3 volts in my case. And then you've got COM, the common voltage that you want to output. And then you select between the 8 outputs by the ABC inputs. Sorry, the ABC inputs. So if it's 0, 0, 0, you get output 0. If it's 0, sort of 1, 0, 0, then you get output 1. And then you can see very quickly why you'd want to inhibit. If you don't want any voltage to pass yet, because you're not ready or whatever, obviously you're going to want to inhibit. Because just having ABC low just means that you're outputting by 0, which may be fine, but it may not be what you want. So you can see here you've got eight different outputs that you can select by the 3 pins. There's the logic showing that, and you can see, you go through all this logic, you can see that if 0, 0, 0, 0, then you end up with output from 0. So it's quite useful. And it's not passing the digital signal, it's passing the analog signal, so you get the proper sine wave or whatever you're passing. So it's quite useful. So one thing that Tony pointed out is that when you switch 0 off, for example, you're going to have this voltage is going to be floating. It's not going to be tied to ground. It's not going to be tied to 3.3 volts. It's just going to be floating. So I think I think it definitely caused some issues under some conditions. But so far I'm getting away without tying that to ground or anything. So on the breadboard, put it on the breadboard, the demux connecting to everything else here. So this is a little e-paper screen I'm going to add into the project later. So I'll have the tube map, and then I may just add announcements or like a departure board or something like that onto the e-paper display. So everything seemed to be working after I figured out you have to tie the inhibit down to ground, as Tony suggested. Kindly, he was quite kind about it. It's a very obvious thing. You shouldn't just leave things floating around. So everything seemed to work. And then, of course, I transferred to protoboard and ended up with some issues. Sorry, this phone's beeping at me. So I had all sorts of very strange behavior. And then I had realized that I had, again, done the same thing I always do, is just have boards lying around, not secured at all. So this one was just sort of bouncing around on my desk. And eventually I destroyed one of the jumper wires. So it was just barely hanging together. But as soon as at one point it just failed completely, and then I can identify what the problem was. Obviously, so at this point, I don't know if you can see, but I've just put in headers here, so I can connect whatever pins I want, just to make sure that I can actually get it working first, and then maybe I'll solder it in later. So here you can see the 0.786 is the floating voltage that we were measuring on the data line as we switched between the two different lines. So it does work, but it seems to barely work. It does seem a bit unstable, and I guess I'm not quite sure. Not quite sure it'll actually work when I start driving it with multiple colors and essentially increasing the power output. So if it's my last slide or not. It's my last slide. Yeah, so if I just show you here.
Hey, Richard.
Yep.
You had a couple of people wanting to jump in on the Zoom meeting.
Oh, sorry. Yeah, sorry, I didn't see that.
Yeah.
Welcome, everyone. Sorry for making you wait. So yeah, so it is working. The pixels are working. I'll just show you here. I'll stop sharing screen. So let me just should be able to highlight myself. Spotlight for everyone. So hopefully everyone can see that now.
I can see you. Oh,
My
wow.
cat.
Meow.
So I guess it's a bit bright. Neopixels are kind of hard to show, but sorry.
Yeah.
So this is, you can see the oscilloscope in the background there, and you can see the blue and the red pixels starting to light, and they're just lighting one at a time. So I guess, so these are not very brightly lit. They're only about 50 out of 250. So they're not very bright yet. I don't know what's going to happen if I start increasing the brightness, as I mentioned. And on the bottom here, you can see the Perspex version. I'll just pull that because it makes it hard to see things. Sorry. Give me a sec. Oops, wrong one. No, that's the right one. So that makes it easier to see. Yeah, so everything is sort of working, but I guess I'm not confident it's going to continue to work. Then one thing that I did notice, I did try, and maybe someone can explain this for me, is if I add in, if I add in the third string again, then it should show the memory address properly. You know, as these blue pixels light up, then I would expect the third string to sort of mimic that. But what actually happens is, if I just attach this one, Um,
Bit like filming fireworks.
so you can see that,
Ooh.
they end up with very strange results with, I don't know if you probably can't see that very well, but there's sort of all sorts of different flashing and essentially random colors going on.
Can you hear me? Yes.
And the blue lights has essentially stopped progressing. So I just pull that again, then everything goes back to normal. So I guess it probably has something to do with the floating voltage and how much I'm trying to drive. I guess I'm wondering whether or not if I start increasing the demand brightness, whether I'm going to end up having a problem with all the other, with the pixels that are on there, even with the two strings. Yeah, so that's sort of, yeah, that's where I'm at. So it took quite a bit of Tony's help to sort through what was going on and figure it out. But it is working to a certain extent. I am considering maybe just adding an extra 4051 and tying that to ground, so that so it's not just left floating there as part of the when I'm not commanding the pixels to light. All that makes sense.
Yeah, Richard. One
Interesting.
thing you could try with the where you got both LEDs plugged in, is plug the second one in and unplug the blue one. See whether it's a fault in the third string or whether it's the combination of the two that's doing it.
Well, I can plug the third string into the first string.
No, just plug the third string back in, but unplug the blue one.
But the third string is connected to the blue one. That was my point.
Hmm.
Creating one long string
Right. Oh, okay. Yeah.
of about 200 pixels instead of 98 pixels, whatever.
Yeah.
Why try and do it all with one string?
Sorry?
Why one string? Because I mean, you've got all the lines. Would it be easier to route smaller, shorter strings along the lines?
Yeah, so the problem is, if I want to introduce, so I'm not sure your question, but I'm just trying to address each pixel individually. And if you
Yeah.
just connect them together, you're actually addressing two pixels at once if you've got two strings.
Yeah.
So pixel 0 for both strings ends up being driven.
I mean, driving.
Demultiplex them.
I think more driving them independently. So you use something like a fade candy board. Without let you drive 8 strings quite easily.
Yeah, so obviously you could buy other hardware to do that, or do it a completely different way without using a Raspberry Pi. But
I was going to suggest the same thing actually, but using the RP 2040s, which are dirt cheap at the moment.
That's another one, yeah.
yeah, so
just
there's lots
use
of
one
different
per
ways
string.
of doing it. But I guess this is one of those cases where I thought, well, actually, it's a good chance to learn something new. Like what, just sort of use an IC chip. I found quite a bit of
Are
fun.
you
actually.
using a different GPIO for each string?
I'm not aware of how you can do that.
This
It's
is
not
being
a lot-
driven as one long string, yes? It's just one long string and you're driving them all off that one long.
Yeah, so you can have one long string with normal neopixels, but this type you can't,
Because
unless
it's
you
not
want-
addressing.
unless you want them repeating, which you may want. I guess I don't know why you'd want it, but it's not to say you don't.
Well, the
I
fairy
don't
lights. The fairy lights, they're just for effect. So You don't want to be programming up every single bit of your fairy light string. So repeating it is a very cheap way of making patterns.
Yeah, I thought that as well, except that the fairy lights do come with a USB driver, and they don't do that. They don't take advantage of that. Each of the 100 pixels has its own address.
Yeah.
I mean, maybe it makes the programming a bit easier. I don't know. I just struggling to know why you would bother.
Yeah, the one specific feature for having addressed pixels that I've seen is that you can route your control channel wiring as more like a tree rather than having to have it as a line, which if you're using normal linear neopixels, you would have to run a straight line, which maybe for your tube map would be when you get to a junction of lines, you'd be able to fork off your light. Oh, sorry. You'd be able to launch you'd be able to split your control wire and go off 2 lines separately.
Yeah.
For example, that's the only advantage that I've heard of for doing this.
Yeah.
In the laser micrometer display I've got running, I run DC out to each string.
Yeah.
But I have to daisy chain the data line from the top end of one back to the bottom of the next one. And so I end up with this maze of this data line going backwards and forwards across the display system. Whereas the fixed address ones would make it so much simpler. It's probably associated with the field wiring.
Sorry, Tony. You mentioned the floating input at 0.78 volts. That's sort of bang in the middle. So that's just what you want from floating input, but you really need to get down to about 0.2 or up to, I think it's 1.8 or something for to have a clear signal one way or the other. So Tony may have mentioned that. The other thing that struck me is that when you were describing your breadboard and the transition to protoboard, it sounded as though the faults you were getting were pretty random, which kind of suggests to me that it could either be power or frequency is another one that does that sort of thing. I didn't quite get what you were wanting to use the multiplexer for, whether you're wanting to multiplex the control signal.
Yeah, multiplexing the control signal so that I can treat each set of each string separately.
Yeah.
At the moment, if I have all 3 strings connected, I've got driving pixel 0 drives 3 strings pixel 0. I want 3 different strings with their individual pixel zeros.
Yeah. You may have already checked the frequency response of the multiplexer, but if not, that may come into it because the WS series LEDs, and I don't know if these are the same, I assume they're similar, they're driven at sort of SPI frequencies, which are pretty high, and the timing requirements are fairly tight. A full-blown Raspberry Pi will have no difficulty with that, but a lot of the smaller, slower micros would struggle. So because you're up at that area and you've got these quite long jumper leads on your protoboard as well as your breadboard, it may be that frequency issues are coming into it and you're getting degradation of your control signal.
Yeah, so there's definitely some issues with the control signal, but it did end up being just a faulty jumper lead. Wasn't quite getting a good connection until it finally just broke.
Yeah, but with leads as long as you showed us on the picture, it might be worth thinking about, whether the capacitance of those is going to be rounding your signal at that sort of frequency to the extent that it gets a bit iffy as the first of the neopixels tries to shape it again and hands it on.
Yeah. Yeah. Still early days, frankly. Still lots of things to screw up.
Just wondering about the power though. Did you like, is it an independent power supply that's powering the lines, the strings?
Yes, I bought a 5 volt, 10 amp power supply.
Oh, 10 amp. Okay, yeah. So
Yeah.
well and truly covered. Okay.
Yeah. So
Richard,
I did. So I've got it powering the Pi as well. So it's just yeah.
Richard, on your multiplexing the control signal.
Yeah.
So you got your multiplexer connects the Pi, your signal driver, to one line. Do you need the disconnected lines? Do they need a pull down on them because their control inputs then floating?
Yeah, that's what Tony was mentioning. It seems to work okay, but
yeah,
I may have to add a separate multiplexer to pull them down, because I did try to add, on Tony's advice, add I put a 1.5 kilo ohm resistor to ground.
Mm-hmm.
But that didn't seem to work, although I might have done it wrong. So it's still, like I said, it's just still have a bit of work to do on it. I thought I would present just because I thought it was kind of interesting, and there's a lot to fill.
That sounds a little on the low side for those frequencies. Maybe a 10K would work better.
Yeah,
You,
maybe.
you need quite a lot of drive. And the other thing that comes from that, I don't know if you've checked the voltage on the far end of the string when some of them are lit up, because that wire might be very thin if it's anything like the only one I've ever seen. And so you might actually be getting significant voltage drop down such thin wires, especially with 3-chained.
Yeah, it's definitely getting some voltage drop. So I do see that, even though my power supply is definitely enough, you do get the classic yellowing. The classic yellowing if you drive full white.
It's not so much the change of color I was thinking of, more that each chip reshapes the signal for the next, and if your power level is varying a lot or tailing off, that's going to interfere with getting a clean signal through to the following chip.
The interesting thing
Yes.
on these addressable ones, data line's actually in parallel with all the chips. It's not daisy chained through them all. And that's how you can do a direct addressing. You can talk direct to the last chip without going through the first lot, the first 99.
Yeah.
Which of those, Tony? That's different to the WS ones.
Yes,
Yeah,
that's the thing that Richard's got, is these are direct addressable LEDs. It's 100 LEDs all in parallel, not daisy chained.
It's the same wire protocol though.
Yeah, exactly.
Yes.
Still using exactly the same way, but
It sounds a better scheme as far as this signal reshaping issue goes.
yeah, because I don't know. I couldn't think of any major advantages yet. Just it's done nothing but hurt me, frankly. If it was normal Neopixel, it would have been fine. It would have been done this project months ago.
You said you got this box of mysterious 2-wire LEDs as well.
Yes.
Can you post some details about that? I'm kind of interested.
Yeah.
Just post the URL online or something.
Yeah, definitely. I can definitely do that. Yeah, I have no idea how they work.
So there are definitely things like Dallas Semiconductor stuff like PubTil. There's a 2-wire protocol. It's called 1-wire, but it's actually 2-wire because they discount ground, and that does power and a data signal over a single wire. And there's a particular distinct look, which is a round circular ID tag that they use with that protocol, which is used in pubs a lot for bar stuff, having it on a little drawstring. on their belt to tag into the point of sale terminal. But that protocol is used for a bunch of other stuff as well. So I've also used it for driving, for talking to thermometers on projects I've done, like hobby projects. It's pretty common as well. So those 2-wire protocols definitely exist for doing power and a bit of data, low data rate.
Yeah, maybe if we got a chance to hook up to the oscilloscope or something.
I got exposed to 1 wire all the way back in the day when the Sun did the Java ring with the secure capsule on it, and it used 1 wire to actually talk to the inside the capsule.
Yeah.
So you only had 1 bit of protocol to play with.
Yep. You can actually get 1-wire key fobs now really cheaply from China. They're knockoffs of Dalsemi stuff. But I've just bought 60 of them for 16 quid, including delivery.
What game are you going to do with those?
Well, it's actually for the laser tag. They're membership tokens.
Yeah, that's like old Laser Quest style tags with those.
That's right. So I've got a very simple board that's got like an 8-legged pick on it, and all that does is it talks 1-wire protocol on one leg, and reads it, and then translates that into a little bit of signal to the gun to say this member's just logging in.
Nice.
I better stop there. So Tony's going to give his thoughts on this problem that we've been working on together. And thanks so much, Tony, for your help, by the way. And
No problem.
Ben as well, identifying what the hell I had. It's not great, you just buy something to hack it and you realize it's not exactly what you thought it was.